In this video, we'll continue examples of linear models and applications. We'll do a motion example and a consecutive integer example. So when we start and we look at this motion example, it says Luca took 1.5 hours to fly her plane from her home airport with the wind. So she's traveling with the wind to Helena. When she returned the next day, it took her 2 hours traveling against the wind to go the same distance. That's key right there, that same distance. If the wind during both trips is 15 miles per hour, what was the speed of the plane in still air? So really, this is our question. So we're going to start by identifying our variable, and I'm going to let P be the speed of the plane in still air, because that's really what we're looking for. And I'm going to make myself a chart. This kind of problem lends itself well to that. And that's because this formula, distance equals rate times time, we can fill in each of these pieces. So if I'm traveling with the wind, then my rate is going to be the plane plus the wind, which is 15 miles per hour. And with the wind, when she travels with the wind, it takes her 1.5 hours. Against the wind, her rate would be the plane minus the wind, and then it's going to take 2 hours. And since we know distance equals rate times time, this is going to be 1.5 times p plus 15 and 2 times p minus 15. And in this particular case, those distances should be equal. So we're going to say 1.5 times p plus 15 is equivalent to 2 times p minus 15 and solve. 1.5p plus 22.5. Can't really tell if that's a 15 in there. Let me fix that. No. Equals 2p minus 30. Collecting our like terms, we'll get 52.5 equals 0.5p. And then dividing, we get 105. So we would answer this in a question. The speed of the plane is 105. And then I'm going to look up here and say, oh, that's miles per hour. So for a distance, rate, time problem, setting up a table like this is a very useful way to approach that. So for the next example here, consecutive integers, we really need to talk about how we represent an even number. So when we represent an even number, it's just a multiple of 2. So we would represent an even number as 2n, and we would represent an odd number as 2n plus 1. So when we read this, when an odd integer is added to 3 times the next consecutive odd integer, the sum is 114. This should be changed here. This is a 4. So if the first odd number is 23, then the next odd number is 25. So we have to add 2. So this would be maybe the first odd number in general. And then the next odd number, we're going to have to add 2. So 2n plus 3. So let's read through this again. When an odd integer, here's the odd integer, 2n plus 1, is added to 3 times the next one, which is 2n plus 3, we will get 114. So we now have 2n plus 1 plus 6n plus 9 equals 114. 8n equals 104, subtracting the 1 and the 9. And then n equals 13. So then it says, find the value of the greatest integer, the greater one. So that would be this one. So we're going to say 2 times 13 plus 3. 26 plus 3 is 29. And then we will say the larger integer is 29. We'll stop there and then do the investment example on the next video. Thank you.